Hey all, Prof. Aram here, and in this video I'm going to go over the very important topic of time value of money. As I mentioned in the introductory videos, time value of money is one of the main principles of finance, and you don't need a finance degree to understand time value of money. It's pretty common sense. Almost every culture that you look at around the world, they have some version of time is money saying. So they know, everybody knows the value of time and how you can basically grow your money. Most rational people prefer $100 today compared to $100 a year from today. But in order to understand finance in general, finance as a discipline, and different things that we do in finance, and understanding and knowledge and a deep sense of knowing time value of money is very, very, very important because it's all pervasive in finance. Wherever you look in finance, you will see time value of money. So let's get to this. Let's go back to the history. If you ask a caveman, would you rather to have a mountain goat today compared to a mountain goat 12 moons from today? Of course they would accept, they would go with the mountain goat today, right? Later on, in agricultural societies, when money was grain, a farmer would borrow grain in the beginning of the season and repay the loan with a larger amount of grain at the harvest time. Today though, we are using money for our transactions. So today we are focusing on compounding and discounting. In other words, finding the future value and present value. So if you have money today and you want to know how much it will grow in the future, you are looking at future value. Or if you are promised to receive cash in the future and you want to know how much does it worth today, you are looking at the present values. So these are central in several applications in finance. We usually use the concept of time value of money in the valuation of stocks, bonds, valuations of projects inside a firm, or even mergers and acquisitions, and in personal finance by analyzing mortgages, car loans, student loans, credit card debt, or retirement planning, or at the macro level, the public finance, you're looking at the social security benefits and the healthcare and so on and so forth. But the beauty of finance is that we can use the same reasoning and tools for all of these applications. The ideas and the math are the same across the board. You can invest the money you have today at risk-free rate, so your interest would be your risk-free rate. Risk, of course, is an important issue in many financial decisions, but here it is mostly ignored. We're going to completely ignore risk in this chapter, and simply because we want to focus and understand time value of money. We will go over the risk in some future chapters. Okay, so here's an example. Let's say I'm giving you $100 today at time 0, $100 at time 1, and $100 in time 2. If I ask you how much would you have at the end of 3 years, some students usually say $300. But that is not the right answer, because the first $100 is not the same as the last $100. Think about this. This one, the $100 that I give you today, has an opportunity to earn interest for 2 years. But this one, the last one that you receive, has a 0 chance of earning interest because you receive it at year 2. In fact, these two are not going to be the same either, time 0 and time 1, because the first $100 bill that you have here is going to earn 2 years of interest, whereas this one, the one that you receive in year 1, is able to earn interest only for 1 year. So the answer is that this value is not going to be equal to $300. It will be something more than that, because the first two $100 have a chance, have an opportunity to earn interest for 2 years and 1 year. Okay, in other words, money over time is not additive. Money over time are apples and oranges and mangoes. You can't add them because they are of different nature, okay, different characteristics. So this is very important. Money is not additive. So if I give you a question like this and ask you what is the future value or how much you have at the end of the 2 years, the answer is definitely not $300. Okay? Time has value because it allows you, or it allows your money to grow. Right? The power comes from the interest paid by the financial institutions. So if I give you $1,000 today, the logical step for you is to put it in a bank and earn interest over the year. Let's say, in this case, the interest is 10%. If you put $1,000 in a bank, at the end of the year, you will have your original amount of 1,000 plus the 10% of the principal or present value of 1,000, which is 100. So our intuition or common sense tell us that the value of 1,000 today is more than its value a year from today. So here now we want to formalize this concept, this common sense thing, and create a framework or methodology that helps us make better decisions, especially when we are dealing with investments that have different characteristics, investments with different time horizons, investments with different interest rates attached to them, investments with different cash flows. So if you want to compare these options they look different and decide which one is the best option for you, we have to use the tools that we learned here that we're going to cover just now. So the first type of interest that we are going to look at is the simple interest. So in the simple interest, let's say your interest rate is still 10%. So in year 1, you will receive $100 or 10% of the original 1,000 as the simple interest, your first simple interest. And in year 2, you will receive your second simple interest of $100. So at the end of 2 years, you will have your original amount plus 2 simple interests, so $1,200. To find out the future value in this case, we can formalize this. The simple interest, the amount of simple interest per period. So this is simple interest per period is going to be your present value, or how much you put in the bank or you invested in the beginning, times the rate of return. And then your future value would be your original amount times your simple interest times the number of periods that you let your money stay in the account. So let's say you start with $7,000 and your interest rate or rate of return is 10%, and you leave your money in the account for 3 years. So your future value would be your original amount of 7,000 plus your simple interest per year times the number of years, which is 3 years in this case. So we have original amount plus simple interest, which is going to give you $9,100. So this is the simple interest example, the simple interest version of the interest that you earn. The powerful one, the more powerful one, is the compound interest. When you allow your interest to compound, this is basically interest on a steroid, on a spinach. So in this case, you allow your interest to earn interest. So compound interest is basically interest on interest. So let's see what I mean by that. Let's say you still have that $1,000 and you put it in a bank, but now the bank, this is actually the title should be compound interest here. Now the bank allows compounding. So what happens in the first year? In the first year, your bank account shows a balance of 1,100, which is your original amount or your principal amount plus the interest for the first year. So 10% of the original amount you receive would be the interest. So at the end of 1 year, your balance would be 1,100. In the second year, you still have the original amount, the principal amount. You earn 10% on the principal amount, and then you earn $10 or 10% of the interest that you earned in the first year. So at the end of the second year, you will have $1,210. So the difference between this 1,200 and 1,210 is the difference between simple interest and compounding interest. So if you understand this, where this $10 come from, then you understand compounding. Then you understand the power of compounding. To formalize that, your future value would be the original amount that you invest in the account times 1 plus the rate of return or interest rate raised to the power of number of periods. It can be years, months, 6-month periods, quarterly, daily, whatever it is. T is the number of periods. For most of the questions, we look at annual rates, but it can be, annual compounding, but your compounding could be any frequency per year, daily, monthly, or quarterly. So T is the number of periods that you allow your money to grow. Here's an example for you to see the power of compounding. The red columns here show the principal amount of $1,000 that we have. So it's the same problem, but we are allowing your money to be in the account for 20 years. So in the first year, you still have $1,000 principal amount plus $100 in interest. As you can see, I don't know if you can notice, there is no dark blue here because in the first year, you haven't had a chance to compound. You haven't had a chance to earn interest on interest. But from year 2, these dark blue columns start to appear. The dark blue ones are the compound interest. And of course, the light blue columns are the simple interest. As you can see, the simple interest shows that if you only earn simple interest, your investment grows linearly at the rate of the interest rate. But with the compound interest, your investment starts growing exponentially. That's the power of compounding. So the first important value money relationship that we want to look at here is that for a given time period, remember, let me remind you the formula. So for a given time period, the higher the interest rate, the higher the future value. So as you can see, when you increase the interest rates from 5 to 10 to 15 to 20, your future value will increase as well. So for a given time period, the higher the interest rate, the higher the future value, because of course there is a direct relationship between your interest rate and your future value in the formula. The second important relationship is for a given interest rate. So again, this is the formula. For a given interest rate, the higher the number of periods, in other words, the longer you allow your money to stay invested, the larger the future value. And it's very interesting because, in this one, I have 40 years. And as you can see, because your number of periods, your t is the power here, so you raise this 1 plus r to the power, you see the exponential growth in your investments. Notice that the simple interest is not growing that much. It's still this light blue column, but the dark blue ones, the kind of the black ones, you see that they are growing exponentially. So this is very key when it comes to investments. That's why we're always saying that you need to start early for investments, because if you give time to your investment, it will grow exponentially. It will grow to a much larger amount than if you want to do your investment within like 2, 3, or 5 years. So time is your friend, is your ally when it comes to investment, when it comes to compounding interest. I hope you find this video useful, and thanks for watching.